In our previous examples working with compound interest, we were given an end value, or the number of times that the interest was compounded per year. But what if the interest is compounded continuously? Our previous formula will not work since we do not have an end value. So we need a different formula in order to calculate the account balance when the interest is compounded continuously. So in this case, we need to use the formula FV, or the future value, is equal to P, the principal, times E, that constant variable we learned about in our previous video, to the RT power. So FV is our future value. Well, we want to know the account balance sometime in the future. So FV is what we are solving for. Our P, or principal, is the initial investment, or the $1,850. E is our constant variable, so it remains E. R is the percentage as a decimal, so 0.065, and T is the time in years, so in this case 5. So now that we have all of our values plugged in, we can put this into our calculator, and we get a future value of $2,560.46. So we know how to use the formula in order to find the future value, but what if instead of knowing how much we have to invest now, we want to know how much should we invest now in order to have a certain amount in the future? So we're still using our example of the 6.5% compounded continuously, but we want to know how much do we need to invest now in order to have $3,000 in the future. So we're still going to use our formula that FV is equal to P times E to the RT power, but FV in this case, we know we want $3,000 sometime in the future. So our FV would be 3,000. P, the amount to be invested now, is what we do not know, so that is our unknown. E remains E. Our R value is still the 6.5% as a decimal, and the T value is still 5 years. So now we are ready to plug this into our calculator, but notice that the $3,000 is on the opposite side of the E to the 0.065 times 5. So what we'll have to do is divide both sides by E to the 0.065 times 5 in order to solve for P. So we get that P is equal to $2,167.58. Now you will notice that I changed the side of the number and the P, but remember, as long as you change both sides, it does not matter as long as both sides are swapped. So in order to have $3,000 in an account after 5 years, we need to invest $2,167.58 now.